Okay, this is a quick review for our quiz tomorrow. This is the sheet that was uploaded to the drive under Unit 2. You should have downloaded it. If you haven't already, please do so and try these problems, then run the video. Okay, problem 1. What is the converse, right? So just a quick review. So converse, a normal if-then statement is if P, then Q. Okay, so the converse is if Q, then P. All right, so Alicia goes to Albany is P, and Ben goes to Buffalo is Q. So we're looking for them to be switched. We're looking for those to be switched, right? So I'm looking for Ben goes to Buffalo. So there it is. Ben goes to Buffalo. Then Alicia goes to Albany. So that's the converse. Okay, which statement is the inverse, right? So inverse is take the original and then add the word not, okay? Symbolically, we haven't talked about this in class, but it looks like this. If not P, then not Q, okay? But we haven't done that yet. That's a little foreshadowing. But we're going to use the words instead. Not P, then not Q. That's the inverse. Okay, so the P is the waves are small, so we're looking for something that says the waves are not small, which is both 4 and 1. So it's either 4 or 1, right? Waves are not small, waves are not small. So it's either 4 or 1. And then we need the Q. This is do not go surfing. Do not go surfing. So if you do not go surfing. So if you not a do not, that's the same thing as a do. If you not times a do not, it's a do. So we're looking for if the waves are not small, then I do go surfing, okay? And that's going to be number 4. Well, there's no word do here. Go surfing is the opposite of do not go surfing, right? So not, do not makes it a go. Okay, 3, which statement is logically equivalent? So this happens when we have a contrapositive, right? So original, right? And the contrapositive. These two guys are logically equivalent, which just means if one's true, the other one's true, and if one's false, the other one's false. So we're looking for the contrapositive of if you are an elephant, then you do not forget. Remember, contrapositive is if not Q, then not P. Okay? So let's do it. So you are an elephant is our P. And you do not forget is our Q. All right. So we're looking for something that starts with the red but knotted, right? And if you not something that's already do not, you get a forget. So it's pretty obvious. There it is, right? You forget. You forget is the not of you do not forget. And notice that's the Q. The Q has to go up front, right? And then the P has to go in the back, knotted. So this is you are an elephant. So this is you are not an elephant. So that's the contrapositive, and that has the exact same meaning. Okay, which statement is expressed as a biconditional? Well, biconditional is when we have an if and only if in the middle. If and only if Q, right? So P, if and only if Q. And I think that one is 3. There it is, if and only if. All right, let's go to number 6. Which statement is logically equivalent to this one? So again, we're looking for a swap. This is my P, and this is my Q. So we're looking for not Q to go first, right? So we're looking for, I'm going to use my new notation here, not Q, then not P, okay? But I'm going to say it so in case you don't remember what I just taught you. So we're looking for I am hungry. We're looking for the not of that. I am not hungry. Okay? There are two possibilities here, right? This one and this one. A and C both start with I am not hungry. And then we needed to end with P being nodded, right? So P is I did not eat. So if you did not eat, you must have eaten. That makes it a positive. Then I did eat, right? Which is this one here. So oh no, sorry, hit the wrong one. I did eat. Then I did eat. Okay, so there's my not P right there. And here is my not Q, right? My not Q. So that is it. That's my contrapositive. Remember, logically equivalent is contrapositive. Okay, which statement is logically equivalent to this one? Same practice again. If it is Saturday, that's my P. The it is Saturday is my P. I am not in school is my Q. So I needed to start with the opposite of Q, right? I am not in school, so that means I am in school. And the only one that starts with if I am in school is 3, so I'm guessing it's 3. Let's just double check. It is not Saturday because the P is it is Saturday, so that's the opposite of P right here. That's the opposite of P. Okay, so number 3 is the right one. Okay, let's take a look at number 12. Which statement is the contrapositive? Contrapositive. Okay, so that means if not Q, then not P. Okay? Of this statement. So a triangle is a right triangle. That's our P. And it has 2 complementary angles is our Q. All right, so if we were to write this one, we would say if not Q. So we would say if, and I'll use our Q here, which is in red. Our Q is it has 2 complementary angles. So if a triangle does not have 2 complementary angles, okay, then, and let's take the blue, not P, right? So if not Q, then not P. So then it would say it is not a right triangle. Then it is referring to triangle, right? It is not a right triangle. Okay, so let's look at these. The only one that starts with if a triangle does not have 2 complementary angles is 4. But there's a problem here. It does not have 2 complementary angles. That's good. So that's my, I should read that. That's my not Q, so that's good. Okay. But then it doesn't say what we're expecting. We're expecting to say it is not a right triangle, but it says it is a right triangle. Okay? So problem 12 doesn't work. At least I don't think it does. And I'll be happy if you guys want to show me in class tomorrow if I made a quick mistake, but I don't think so. Okay, number 13. Which statement is the converse? The converse is we swap the P and Q, right? So I'll underline P and Q again. So the P is the sum of 2 angles is 180, and the Q is the angles are supplementary. So we're looking for that to lead with that. So if the angles are supplementary, if 2 angles supplementary, then their sum is 180. We're looking for that, and that's actually number 1. Okay, converse. All right, let's move on to 14. Which statement is expressed in the biconditional? Again, we're looking for that keyword if and only if. There it is. So that's number 3. What is the inverse of the statement? If Bob gets hurt, then the team loses the game. So all that means is we take the P and put a not, and then we take this one and put a not lose, right? But so this is a little tricky. What is the inverse of the statement? If Bob gets hurt, so it's if Bob does not get hurt. So if Bob does not get hurt, which is really here, so it's really the only one, then the team does not lose the game. Okay, not so tricky. 16, given this true statement, if a person is eligible to vote, then that person is a citizen, which statement must also be true. So what must also be true is the contrapositive, right? Contrapositive. So we're looking for something that says the Q and knotted. That person is a citizen. So we're looking for something. Juan is a citizen. Kayla is not a citizen. Okay, so that's not Q. And then a person is eligible to vote, so she is not eligible to vote. So that works, right? So it's number 1 here because this is not Q. This part here, Kayla is not a citizen. That's not Q. And not eligible to vote is not P. Is not P. Okay. 17. What is the converse of the statement? If the sun rises in the east, then it sets in the west. So that's easy. Just swap them. So it says if the sun sets in the west, if the sun sets in the west, then it rises in the east. Okay. 18. Which statement cannot be written as a true biconditional? Okay, so we have to just look for the one whose converse would be false, right? So number 1, we'll do number 1 first. If 2 lines are congruent, then they have the same measure. Well, actually, lines can't be congruent, so that's actually can't be written as a biconditional right there, so it could be number 1, but let's just check the rest anyway. If 2 angles have the same measure, then they are congruent. That's true. The converse is if 2 angles are congruent, then they have the same measure. Number 3, if 2 angles are vertical angles, then they are congruent. That's true. Let's take the converse. If 2 angles are congruent, then they must be vertical angles. That's not true. So the book, wherever we got this from, they meant for problem 3 to answer 3 to be cannot be written as a biconditional, as a true biconditional, okay? But problem 1 is flawed, or choice 1 is flawed too, because lines can't be congruent. They really meant to say line segments here. And if they had said line segments, then problem 1 would work, so we wouldn't mark this as the answer. If it said if the 2 line segments are congruent, then they have the same measure. The converse would be fine. If 2 line segments have the same measure, then they are congruent. Okay, and number 4, if 2 lines are perpendicular, then the lines intersect to form congruent adjacent angles. Okay, like that. And if 2 lines form 2 congruent adjacent angles, intersect to form 2 congruent angles, that would also mean the lines are perpendicular. Okay, so this is fine too. So the answer is really number 3. However, number 1 had a flaw in it, choice number 1. So just a weird problem. Okay, 22. Write this in symbolic form. We're not going to do this, but we will do B. So I don't know if I signed 22, but if I didn't sign 22, pause the video and try it right now. If I did, then we're just going to go over B. You don't need to know how to do A just yet. Okay. B is the inverse. What is the inverse of the statement? If I do not buy a ticket. So inverse means I have to say then if I do buy a ticket. If I do, that not's a do not, right? I do buy a ticket. Whoops, sorry about that. Okay, then I do not go to a concert, so then I do go to a concert. I do go to a concert. Okay, which one of these says that? What is the inverse of the statement? If I do not buy a ticket, then I do buy a ticket. So if I buy a ticket, okay, so this is good. If I buy a ticket, those are both I do buy a ticket. We just left the word do out. And it has to end with, then I do go to the concert. So that is, I go to the concert, right? That's the same meaning as I do go to the concert. So that's choice 2. Okay, given the definition, an isosceles triangle is a triangle that has 2 congruent sides. A, rewrite this as a conditional statement, right? So if a triangle is isosceles, now you may have said if it is an isosceles triangle. That's correct, but this is better English. And we said we want to try as hard as possible to impress our English teachers. So if a triangle is isosceles, then, don't forget we need then, right? The if and then. This is my P in the middle. Now comes my Q. Then it has, now you can say it, right? Now you can use a pronoun. Now you can say it because you used a noun at the beginning. So then it has 2 congruent sides. Okay, that's pretty easy. B, write a statement that is logically equivalent to the statement written in part A. Okay, so what that means is we have to swap our P and Q, and we have to not them, right? Because that's the contrapositive. So we have to swap the P and the Q. Here's my P. Okay, that's my P, and here's my Q. So we have to swap them and put not. So the Q says it has two congruent sides, so we have to say it does not have two congruent sides, but we don't want to lead with it because that's a pronoun. So we say if a triangle, because that's the noun, we're going to keep the noun in the front. If a triangle does not have two congruent sides, I don't think I'm going to fit it, so does not, right? Does not have, and I'm not going to fit it, so I'm going to just see if I can grab them. Does not have two congruent sides. Okay, sorry, it's still a little crowded. Then we got to do the not of P, not of P. So it's not isosceles, right? So then it, now so I can use it now because I put the noun here, right? And this is my pronoun. So then it is not isosceles. It is not, right? Because we're knotting the P. It is not isosceles, which is very difficult to spell, so be careful. All right, that's B. So this is A. That's B. We just wrote the contrapositive. We just swapped the P and Q and knotted both of them. Okay, and then C says write the given definition as a biconditional statement, right? So biconditional just means right smack in the middle, you put if and only if, right? So we write the P, we write the Q, and then we would put if and only. So no, I don't start with if. Don't start with if. So we just say a triangle. I'm doing this for the original, right? I'm doing it for the original. A triangle is isosceles. Here it comes. I'll change colors to help you out. If and only if. You don't have to capitalize it. I shouldn't have. And I shouldn't have made a mistake. If and only if. And I'll go back to blue. And we'll write Q, right? And Q is it has two, I'm just using the number 2 here to save space, congruent sides. Okay, so I just took the Q, I took the P, I wrote them both. I did not put if, I did not put if and then, I didn't use if and then. I just wrote the P, here's my P. I wrote the Q at the end, and in between, I put if and only if. That's how you write a biconditional statement. On the quiz, don't forget, I'm going to ask you, is the original and the converse, which we didn't do here. Is the original and the converse true? And then you have to decide if you can write it as a biconditional, okay? If you did take the converse of A, which we didn't do, but if you did, it would say, if a triangle has two congruent sides, then it is isosceles. That is true. So both the original and the converse are true, so it's okay to write this as a biconditional. But you'll have to determine that tomorrow in the quiz. All right, so try this one really quick. Just write the converse. This is exactly what we're talking about. Write the converse. Determine if it's true, if both it and the original, right? It meaning the converse. So determine if the converse and the original are both true. And then if it is, write it as a biconditional. Okay? All right, so if x is greater than 0, then x is a positive number. That's true. Let's write the converse. We're going to swap the P and the Q, right? So if x is a positive number, then it is greater than 0, right? I really should say x. I shouldn't use a pronoun here, right? Because we're using mathematical statements here, then x is greater than 0, okay? So if x is a positive number, a little number symbol for number, then x is greater than 0. That's also true, right? This is the converse. Okay, oops. Okay, so when the original and the converse are both true, they're both true, that means it's a biconditional statement. It also means it's a definition, remember, right? It also means it's a definition. We said that in class many times, definition. All definitions are biconditional, and all statements that are biconditional are definitions, okay? So we're going to rewrite it in the if and only if format. Okay, so what do? We write the P. Notice there's no if. x is greater than 0. Now we write if and only if. We put it in the middle, right? Here's P. This is my if and only if statement, and then Q. X is a positive number. I'm just going to write the number symbol for speed. Okay, and here is my Q. And I think that's all the problems. Okay.